Hello, everybody, and welcome back to episode 46 of the Swiss AI Engineering podcast called This is the Year. Yet again, with me today is Joao, the AI engineering wizard. Today, we have a few topics prepared for you guys. We're talking again in regards to agentic AI harnesses. We'll also talk briefly about skills. We'll deep dive also today into Claude Dispatch, Claude Cowork, and Claude Code, specifically how to actually use it to then sell your agentic AI software. But before we actually talk about that, Joao, you have some nuances to add in regard to DeepSeek's research. But first, you're back from vacation from Italy. How was that trip? Did you do what you had intended to do?
I did. I have some opinions about Italian drivers and their understanding of the driving laws of the country. I tried to abide by all the rules and laws that I saw, all the traffic signs that I saw. It seemed like I was the only one trying to do that, but maybe I was reading them wrong. I didn't have time to take a screenshot of every single traffic sign and post them into Gemini or ChatGPT to see if I was maybe misunderstanding what the sign meant. But EU traffic laws might be different things across different countries. But it was, in general, quite fun.
Excellent. Well, good to see you back in the game. We talked about today very briefly. You were out for roughly a week in AI time scales. That's around a decade. So a few things have changed. Maybe just for the audience, we have been shooting these episodes for probably roughly a year now. And if you have a question in regards to applied AI engineering, being, for example, building agentic AI products, feel free to drop a comment. We're launching these episodes every single week, basically just sharing what we've learned in the last few years of building and also selling agentic AI software, mostly in Switzerland, to regulated industries in finance or infrastructure topics. And why don't we kick it off with this first, let's say, a bit of an update. The last few episodes, we talked about harnesses and really the benefit of harnessing one particular agent. Yet I've actually received from one of my AI classes that I'm teaching the last few days, I would say increasing requests in explanation. Why do we harness only one agent, or is this like a whole multi-agent system fully dead now, and we have the single agent system with one particular harness again? Or what's your viewpoint? Multi versus single agent, multi-harness versus single harness, and how is this whole tool landscape then evolving? Try to make sense a little bit of that, Joao.
I see that. I think the optimal solution is to have a little bit of mix, but multi-agents showed up around a year or two ago, and they looked really interesting. And you could set them up in different structures. You could have a supervisor agent and multiple like single task agents. It's exactly like how we envision like companies work, like those organograms, just having every single agent has a specific role. It almost sold the dream that you could replace your whole company or at least part of a department with agents. The thing is, software-wise, it is incredibly hard to do multi-agent systems, especially because regarding handoff. So people in companies talk, even if they're not in the office, they'll talk via Teams or Slack or WhatsApp if you want them to. They'll share information. And when you set up these agents, it was hard to know when to share information and what information to share. And so most multi-agent systems not only were difficult to build to begin with, but also they were difficult to maintain. And then you'd add a new feature. Maybe was that feature a new agent or just expanding an existing agent? And you were always trying to play a balancing act. And so you had the concept of these like tools and skills, which is just instead of having multiple agents doing different things, like one agent exploring files, one agent reviewing compliance documents, you can have one agent that could have different skills that you could pull in real time. It could see, okay, how do I read compliance documents? And it goes to read compliance documents. Okay, how do I go online and search for this information? And we'll get the tools to go online and search for it. That seems way simpler, and it is way simpler to set up, like from a perspective of codes, but also from a perspective of you're building an agent. This can do multiple things, like having one very effective, very functional employee at your company. The thing is, AIs are not, super powerful just yet. They are quite powerful, quite intelligent, but they have their limits. And eventually, with enough skills, with enough tools, you'd have an agent that would just start to hallucinate. You'd have agents that would go on a different direction that you want them to do. You want them to read compliance documents, but maybe by a bit of an error, it puts the wrong skill, and it's now going through your files on your computer, searching for something else. And so you have, again, a balancing act. what I found out is that most, like the big brand, big name agent systems are doing is a mix of multi-agent and multi-skill. So you have one main agent that can pull different skills, and you can add skills according to your business. You can have skills that are built by the employees, so that the agent can help them and help them the way that they want them to. But for specific things, you can have an agent just for that, just dedicated for that. And you see them mostly for exploring and searching files, which is a very specific thing. It always involves reading a lot of different files because it's hard to know what you're searching. I mean, it might not be in your first or second result, so you might have to read the 5 or 10 top results. So in those cases, you use a smaller LLM, a faster or cheaper LLM that will just go through your files. It's specialized for that, and it'll give you the results you want. And the main agent can focus on what matters, your business logic, your business skills. And if it needs some information from some files or from online, it can pull that explore agent or that search agent, call it whatever you want, and call that agent, have that agent do, let's say, the boring work of reading through things. And that agent will return the information. The main agent can just use it however they see fit. I think this mix works the best.
I mean, it's probably just a balancing act. I think overall, I think one question that usually yields from that is it's usually context dependent. Whatever the software actually has in mind to execute. I think what we've seen more and more is actually happening, that you have some sort of main intelligence agent or main large language model that you're using for the heavy lifting of the tasks. Like, for example, in our case, it's like Excel modeling or PowerPoint slide generation or doing some deep research. You probably need a fairly, I would say, capable model that is harnessed with all the skills and all the tools it actually needs to execute on this. And then you maybe spawn sub-agents that you still have some sort of control over from a builder's perspective, because you would want to have the cost under control as well. So you don't give full autonomy to the system that can just spawn left, right, and center new agents and then automatically tool calls, and you don't really have much control over that. Again, for two reasons. For the pricing perspective, you would want to have a dedicated, I would say, system in place when complexity task X, Y, and Z is happening. Maybe a cheaper model is being pulled into the loop of action, so you can actually minimize and reduce your cost. And then second of all, also from a governance perspective, I think just free-floating agents all over the place in certain industries that we are focusing at, for example, finance or infrastructure topics, public sector. You do not want to have, I would say, too much of a I would say flexible design that you cannot trace, that you cannot log, and there is no governance structure on top of this. So it's always a bit context dependent if we sum it up. And certainly one particular component is like, if you're building an agentic system, or maybe you have your first agentic product, or I would say maybe even a few AI agents in your product, what your ultimate value proposition really is, and that becomes increasingly clear when you talk to initial clients, is like all this handling between what we've just talked about, managing multiple agents, potentially multiple cloud providers, potentially multiple model providers, potentially 100 plus connectors and tool accesses, all these APIs, all these keys, all the shifts and replacement, the continuous testing, regulatory needs, new connectors, new capabilities. That's really all out of the box that you as a builder, you can provide to a business. And this whole overhead of the operational integration, the monitoring, the retesting, the security is ultimately what you're selling if you're actually selling an agentic or multi-agent system for whatever the task may be. Last time in our episode 45, we talked about outcome-based pricing. So this whole agentic system would then yield to an outcome, and this you can price accordingly. For instance, executed, or maybe in other words, sometimes saved for a full-time equivalent of an employee. But that's more or less just a very brief, again, nuanced update on harness engineering, harnesses and agentic skills, tools, and connectors. It really depends on the context. Ultimately, the value proposition is fairly obvious, that you reduce the complexity to whatever enterprise or clients you're actually selling to. I give you back the word, Joao. Mentioned some research by DeepSeek before the show. Why don't you give us a bit of a rundown? What happened and what's the implication on multi-agent and multi-harness and multi-tool systems?
I'm off for a week, and when I get back, I start to read what's up in the academic world, of AI. And again, we're not officially sponsored by DeepSeek, but let's say highly motivated to read what their output, because they have been pushing the boundaries in terms of this AI and machine learning research. And this last research, usually it has AI research comes somewhat structured in a way that there's a new architecture, a new mechanism for models to use. You implement it, you test it, you across benchmarks. It's better if you things, worse it's a few others. You make the comparison, that's it, results, and you have a paper. You publish it. The thing is, it needs latest paper, and it's a very long title, something to do with conditional memory, via scalable lookup, a new axis. Like it is a lot of words. But what actually means is they come up with a system, and when I test across different benchmarks, it makes the model better at every single one of them. So from math questions to trivia questions to understanding text, the model gets smarter across the board in all the different benchmarks they threw at it, and they threw quite a few different ones at it. So I won't go too deep or too nerdy about the mathematical approach that they took into this, but in an analogy, instead of having the model try to understand every single word from scratch, like the models do now, like ChatGPT, Gemini, Anthropic, Claude models, if you say something like Alexander the Great or capital of France, the model will read every single word and then construct meaning out of them one by one. So Alexander the Great, you'll try to understand Alexander, then the Great, mix them together, and then you'll come up with a famous historical person. They came up with some kind of a table lookup mechanism that you can mix together words, and mixes of words and small sentences have meaning by its own. So capital of France, Alexander the Great, or a piece of code that's usually often used, they can store the meaning of those things in a table and then look them up in real time. This means that when you're processing some requests, when you're asking something, the model can store their knowledge, not just across the weights, but in a very specific table. And that means the model can have focus on then mixing like business logic and mixing its logic with the facts, and not worry about just remembering the facts, which is something that we noticed in different models. You saw like very large models and very small models like Gemini Pro and Gemini Flash, right? Google usually launched a bigger and a smaller model. And the bigger model knows all the facts, and the smaller model is fast, but tends to forget them because it has less weights and thus less knowledge embedded into those weights. This approach would mean that the knowledge is put into a different table, not the weights, that the model will pull in real time from. Again, it's a very high level overview. Mathematics is way more complicated than this, but it means that the model, even if it's a smaller model, can have a very deep insight, a very deep information about facts, about data that was trained on. This was very like bleeding edge research, but I'm seeing that this will be applied in at least the next wave of LLM that we're going to see across the board, from OpenAI, Claude, Google, definitely DeepSeek. And we might see that we have different lookup tables and different information tables for the same model. And so we have the same model that's specialized in finance or biomed or different industries, and you can have different tables and keep the tables small and efficient. And you might see this hyper specialization of models across industries. Again, this is an informed opinion, not a prediction, but we'll see. I think this is probably for the next few months the future of LLMs, and I'm waiting to see what DeepSeek comes up next, because again, for research-wise, they are really pushing the boundaries.
I mean, as you mentioned, I think one of the key questions has always been, and the answer usually was, we need to generate these agentic skills, right? The question usually was, how do we yield tacit knowledge of an organization, first of all, and then how do we actually inject that into an agentic system? We talked about harness tools and so on. And of course, the missing element so far was the skills. It usually was in Markdown. It was like, if you just reason through the fact that we had to actually prepare Markdown files to then give it to an agent, and this is like the actual de facto avenue that we're injecting this knowledge, was kind of a funny anecdote if you ask me 2-3 years back. But that's basically what is happening now, right? So we have markdown files on generating, for example, due diligence, on doing an infrastructure project, on doing some specialized model for chemistry or for finance, for example. At least if you're building on large language model. What you're explaining is maybe one step after this, probably still somewhat generic to the organization if the org doesn't manage the lookup tables. But probably it is one next logical step, maybe into a world where there is more specialized large language models available as opposed to general purpose one. I'm still sometimes a little bit skeptical on the super specialized models because it kind of is, it's a bit like I would say fiddling out in terms of capability maybe, but certainly I'm very, very open to be testing multiple large language models for our domain, maybe as I would say maybe as part of the agentic systems that are in place already. So whoever is then doing the agentic work on due diligence or on financial modeling or on risk modeling, you might actually want to rely on a Claude model that's purposely built with lookup tables for finance or for risk management or for banking. And for the general purpose orchestration, tool calling, web research, you might actually look for a different model. So that actually in sum really sums up again the counter argument at the beginning you mentioned, multi-agent.
And yes. Have one, if you're not interested in hyper-specialized models, and I understand that it comes with a catch, right? I mean, a hyper-specialized model in finance might not have something in healthcare, and then you're doing financial analysis of a healthcare company, you kind of lose on some information. However, one other advantage that this research brings is that these models saved on compute, which means for the first time in a few months, and we've talked about it, every single new model was coming out better and smarter, but also significantly more expensive. And that was being the trend because the models was growing bigger and bigger with more information and more weights and harder to run for compute. This means that the first time in a few months, I can actually have an architecture that I can deploy on a model, an existing architecture, and I can make the model run equally as smart or even smarter for a little less compute, which makes it a little cheaper to run, which means maybe not the exact next wave that'll come out in the next few weeks, but maybe in the next month or two, we'll see a model that is actually cheaper for the first time. Or not, maybe OpenAI will make the margins better for them. They do need the money, but they can run the models in a cheaper way, which is better for everyone, energy-wise, cost-wise, and hopefully for the builders, they'll spend less on inference and more on marketing or any other topic that they want to.
Or, I mean, the other way is like, given the same money spent today, if it's a more efficient model, they can yield a higher intelligent output version.
Yeah.
So that's a little bit the other way to look at it. Then the third way is like, I think the latest benchmarks from NVIDIA and the Vera Rubin system are also showcasing in association with the low latency components they now received from Grok, plus this multi-chip design or in an entire rack, that again, probably the inference capabilities are going to 10x potentially, plus we have a software or algorithmic improvement by, for example, DeepSeek. So 10x cheaper, 10x faster on the chip, so it's like 100x better overall system. Of course, more or less an estimate here. But that's just to put it into perspective, right? So today we're thinking Claude Opus 4.6 is fairly intelligent for most tasks. If it's harnessed well, has great tools around, great connectors and great skills. The lookup capabilities in the table you mentioned and add better compute, especially on inference. What is 100 times better an Opus 4.6? It's not comprehensible for a human, of course, probably is not as linearly improved than as just 100x from today's baseline. But even if it's 4 or 5x, what does that actually even mean for intelligence? I think that's really, really an interesting future. Just to round up the episode before we shoot, and we need to go back to engineering topics, I quickly wanted to bring across maybe the point. I've tested this fairly intensively the last few days in regard to Claude Dispatch, Claude Cowork, and this kind of computer use from the phone. For you guys in the audience who haven't maybe tried it, you can technically steer your entire laptop or your entire agent on the laptop from Claude via your phone. So that is this feature that Anthropic launched called Dispatch. The way I use it, so basically I have a workflow on on Claude Cowork, for example, or on Claude Code. But let's leave that for separate conversation. So focused on Claude Cowork, that is basically the outbound engine on qualified lead generation. So what that means, once you have an agentic AI product, you probably want to reach out to your enterprises, to your target clients. You have some sort of ICP, ideal customer profile. And all this aggregation work you can have always been able to do on Claude Cowork. You need integrations into, for example, Clay as a data aggregator. So in other words, where you get the company information from, and into Apollo, where it actually yields the output sequence. For this, as it was actually happening for the last few weeks, you needed Claude Cowork installed on your laptop. This saved me probably 60 or so hours per month. It is an insane improvement on productivity because you can simply chat with Cowork and it flies off and does the agentic tasks. I need to do it on Clay, I need to do on Apollo, then it generates all the sequences and the outreach email. Now on Dispatch, I can do the same, but from the phone. So in my case, I might work on the laptop, doing this work, and then just switch off, go to the gym or go to a client meeting on the train or something similar. And I can just continue working like I would actually be at home. And it's kind of a scary moment. I share it with a dear friend of mine who is not too much into AI. And he was also a little bit, what is actually happening? So you can really see, you can steer your laptop, for example, in this sales outreach or SDR pipeline from your phone entirely. And you can spawn agents on your laptop, in your browser. You can even switch between different windows and stuff like this, all from the phone or via Claude Dispatch. Is it a game changer? Not necessarily, but I'm even now more FOMOing that I should use Claude even more on the phone, on the laptop. And today I don't have it as a background, but usually I'm even in the background of Claude Code. So that's the wrap
And
up.
Anthropic thanks you for your usage and for your monthly bill of Claude
Exactly.
credits.
Worth $200, and it literally saves me. I mean, this is like $200, but if you could translate it into the hourly saved, this is definitely worth more than $200. It's probably north of 4 figures if you look it into an hourly rate. But
Don't
yeah,
let
that was it
Anthropic hear
for
you.
yeah, that was it for the episode, everybody. Episode 46, brief drill down into, again, agentic harnesses, into some newest and latest research of DeepSeek, something we maybe actually are seeing more and more in the latest models, and just our best view on Dispatch and on Cowork. Anything else to add, Joao, for today's episode?
No, so far. I mean, I'm still looking at new research. We'll probably bring it you in the next episode. We still have some news from NVIDIA that they're also using AI, but they're not being as loved by the customers because people are getting used to what AI looks like, and when they see AI slop, they recognize it as AI slop. But we'll leave it for the next episode. We don't want to keep you too long. So see you next week.
Alrighty. See you in the next week and have a good week. Take care. Bye bye, everybody.